It's awfully windy out there. Hello, everybody. We're still early. Hello, everybody. We're going to start in about a minute. Well, it's 101, so why don't we begin? Hopefully everyone had a nice spring break, a little staycation or whatever. Knowing all of you, I imagine you are all probably still doing work and that sort of thing. But if you were not, good for you. Take some time. But now, as we begin this final push to the end of the year, you should have received an email. You and your family should have received an email regarding how the end of the year is going to work out. And so what I'll do is I will address a few of the things that we have to do as a class in terms of how the year has to look and then how it relates to us specifically. And then I can open up to any questions. If it's a district type question about what about this, what about that, I'll answer as best I can. Any physics questions, of course, we can do those as well. So first, it is required that we take attendance as teachers. Attendance has to be taken so that it's not really so much as a way to police you. It's really just a way to find out who hasn't been participating and let's figure out why. Not in a mean, sinister kind of way, just in terms of, hey, you haven't been here, are you guys okay, kind of a thing. So I do have to take attendance. So we will do attendance simply through weekly Google form questions, a question or two, or maybe 5 or 6 or whatever else, some kind of a question that pertains to what we are doing that week. It's time stamped, and it just that way it shows that you have logged in, so to speak, to the class and you are participating. The Zoom meetings are going to remain optional. You don't need to come to any of the meetings. They will remain optional. I'm not going to take attendance off of the Zoom meetings. It's just a way for us to connect. So it'll be our Google Forms, and as well as your Utexas assignments. Deadlines and due dates are just mere suggestions. They're, well, like I said, they're suggestions. You should have this one done by this time if you're working at a moderate pace. If you are working at an elevated pace, you're going to get done quicker. And if you're kind of dragging your feet, it might take you a little bit longer. So if something closes on you and you can't submit any more answers, you just let me know and I can reopen things, because pretty much everything I use requires a due date be put in. So if something needs to be reopened, don't be shy, ask, and do those. When it comes to grading, there are no grades. You are getting credit or no credit for this semester. And obviously credit means 60% or more, D- passes. So basically what I'm going to do is I'm just going to use your attendance that you're showing that you're present, and I'm going to use your UT assignments. If those things are all being completed, then you have passed. You don't need to write out a paragraph telling me why you think you passed. I simply have the evidence right there. Look, they checked in each week and did the answer. They've got all their UTs completed. And so that's all I'm gonna be looking at, obviously, so that's what we'll be doing there. If there's old online you need to get fixed up or whatever else, you can do those, but that's not necessary. So those will be the ways that we go forth and end up with a grade. So if it looks like you haven't been involved on a part of anything the entire quarter, then you will have the opportunity to write out a paragraph and tell me, and I just forward that on to whoever needs to see that, why it is you feel you deserve a passing score despite not being here all April and all of May, because you might have a very sound reason, maybe illness or whatever else. So the paragraph will not be required if you are simply turning things in on time, and then you're good. That's it. Since there's no official ABC traditional type grade being done. The Zoom meetings will be optional. We'll keep them at the same hourly time, second hour and third hour at the appropriate time. So 10 o'clock, 1 o'clock, 1 o'clock on Mondays and 10 o'clock on Wednesdays. We'll keep those. I don't see any reason why you can't log in unless you got something else going on, of course, but again, it is optional. So again, make sure you are, learning without fear of grades, kind of a thing. That's what we'll continue to do. I posted the last week's worth of electricity stuff. I posted it going into spring break for those that were going to continue working. If you checked out for a week, as you were entitled to do because it's spring break, this week there's nothing new that is going to be added. I might start posting a few more of the online assignments that have, endless due dates for those that want to kind of continue working forward. So, so there's nothing new this week at all regarding any content. We have our AP exam. We'll talk about AP exams and all that here in just a second. So we've got our AP exam coming up, so we will prepare for that. And we will also continue with magnetism. I will, starting next Friday, start posting things on magnetism. There'll be some online questions that'll go along with it, but that's about it. So I need you to see that information. And every AP teacher out there, whether it's every AP teacher in the building at Adams or across the district, is all doing their own thing. I know plenty of people are saying, hey, we've covered everything that's going to be on the test, so we're done. That's not my philosophy. This isn't an AP test class. This is AP physics. So we are going to continue with magnetism because, like I said, I've got, seniors, we still have 5 weeks, 4 weeks, 5 weeks. We still have all this time for me to say, hey, you know what? We're good. I think that's, I think that's not me kind of giving up on my job. Personal opinion, and I'm not going to be doing that. So we will continue with magnetism. It'll be posted notes, be explaining it as always. Here's an online assignment. And like I said, if I see that they're getting done, I'm not looking for 95% on your online. So if I see that they're getting done and I see that you're progressing through the class, you're asking questions, all that kind of stuff, then you're good. We'll pass online assignments, count for participation. Basically, if you, as long as you finished off the first, as long as you finished up on March 11th, as long as you had a 60% or better, then you're good. And as long as you participate from here on out, there's another 60%. You're good. So the chat question of previous online assignments and tests and all that kind of stuff, as long as you were passing, and if you weren't, then you just say, hey, can you reopen up those old online so that I can show you that I'm passing? And once you get to 60%, I mean, hey, that's what they want. That's what the rule is, I guess. So fine with me. So if there's any questions on that, there isn't really a way for us to do any kind of a test retake or anything like that. So, so like I said, I'll just look at what you had before, and I'm pretty sure everybody was passing. And but you can check it on your own grade to see if you were passing, and then if you were, then you're fine. You don't need to worry about any of the old stuff beyond just AP test preparation. Notes are still just being posted, so the notes will be like I've been doing them. So I will do a voiceover of the files that I have from last year, the SMART files that I have from last year. I will do a voiceover for those so that you can kind of go through and see everything. You've got your book, and then you're online. I'll post all the resources from Edmodo, put them onto Google Classroom. And like I said, that way you can kind of go through those and spend a couple hours each week on that. So I don't plan on overloading you with new magnetism stuff and expect hours and hours and hours of magnetism each week when you have an AP test to continue to prepare for. So plus some people aren't going to be taking the AP test. So again, it seems to me that if I just threw my hands up and said, we're done, I haven't gotten through, nearly as much as we need to. So we'll do as much as we can, but I'm not going to overload you. I still want you to be able to perform well on the AP exam through preparation and review and all that kind of stuff. So in terms of stuff in general, grading and attendance, pretty simple. Just, I'll start posting those Google form. It's a survey, but it'll have some physics questions on there. So I can say, look, they showed up each week. They did each question. Their onlines are completed. And that way there's no doubt. Not that anyone in this time, with what's going on, no one's going to be questioning that. But that way I have evidence and data that supports your passing the class. Now, before I get on to the AP test and what I've put together for you, are there any questions in general about RCS, about grades and attendance and things like that I can clarify? Whether it's through the chat or the unmuting of your microphone. And obviously, if something comes up, throw it on the chat there, and I can address it towards the end of the, after we talk about the AP test. We'll continue then. And at the end, if there's questions that you realize you didn't ask them at the end or put them on the chat. Regarding the AP test. So what I had done, and I sent a message out to everyone, so in case you had not seen it, what I had done is I went on and I found as many links as I could in terms of what I thought would be relevant for you. So what I'm doing is I'm scrolling down on our Google Stream, and so you'll see, and some of you have already done this because you're just on top of things, and other people, you haven't done it yet, and no problem. So you see my cursor on here, the schedule and the test format. So basically it kind of gives you a list of everything, all of your AP tests. We are the first test, which is going to be May 11th. So it looks like everything kind of got pushed back 1 week. We are on May 11th. The mechanics test will be at noon, 12 o'clock. You are going to be given 2 questions, and I know AP biology is the same because Mrs. Lohr and I talk to each other. So it sounds like maybe a lot of your AP tests might be like this. You are going to get one long, they call it the long free response question, followed by a short free response question. You do them one at a time. So starting at noon on Monday, the 11th of May for mechanics, you will take a question. As soon as you open it, you have 25 minutes to read and reply. 25 minutes. You have 5 minutes to upload. So maybe in case you have a bad link or whatever else. So basically you've got 25 minutes and then you upload that question to the cloud or something. I don't know. That's going to be worth 60% of your overall score. You will then be able to open up the short free response question. You cannot go back to the long. Once you submit it, it's done. So you go to the short FRQ question. That's going to be 15 minutes. That's going to kind of be more like our standard AP Physics FRQ questions. You used to get 3 assigned to you over a 45-minute period. You do the math, 1 question for 15 minutes. So that's going to kind of follow that. 15 minutes to do it, 5-minute uploading, 40% of your total. So it's a 60-40 weighting. We in AP Physics C, the calculus-based version, we are not used to these 25-minute type questions. It's expected to be 15 minutes each, relatively speaking, and obviously if you find one to be easier, it saves you time on the harder ones. So what we have on here, going back to the screen, Open Note exam tips. When you click on that, one of the first things, let's see if I can click on it and not like lose my page. Okay, good. You click on it, like one of the first things it says is, these are not easy. So very first one, they are not easy. You still need to prepare. More materials aren't better, etc. So you can go through that as you want. Long FRQ example. This is everything I have found is something that you could have found, you have access to. So they said AP Physics 1, that's the algebra-based AP class that we don't do. They do more material but less depth. They gave us this example. So question number 3 from the 2017 exam, I got a link to the exam. You find question number 3. The solutions to all of them. Obviously, we are interested in question number 3, and then sample responses from students. And I haven't looked at the sample responses, but typically what they do is they show you like good, better, best, or like, you know, good, medium, not good. And so those are all on there, the long examples. The short examples are from an AP Physics C, calculus-based hour class example from 2012, question number 2. This one is one of the, and we've talked about them, not at any kind of length, but we've talked about questions involving setup. Here's some materials. How would you set up a lab that proves conservation of energy, or how would you show acceleration, whatever. So basically it's you knowing the material, but also showing how you could relate it to a lab. And so you would just kind of write out that way. So think about this. You can't really do mathematical type questions typing into a word processor. How are you going to show your work for Coulomb's law? It doesn't make any sense. So the questions are going to be a little bit more, a little less math and a little bit more, let's rephrase that, a little less math calculations and a little bit more of the examples behind math and the concepts, qualitative versus quantitative. Hey, this thing tripled, which means this value is going to go up by 9. Those types of relationships, graphical relationships, and again, showing a lab and how it can relate. So what happens when this thing goes up? You're not calculating, you're explaining. If this goes up, this value over here is going to remain the same. Those types of questions. So you get a good example there in question number 2, solutions and some samples as well. So let's see here. When you go on to the E&M page for the test, everything is the exact same, literally the exact same. The difference is this test is going to be at 2 p.m. instead of 12 p.m. So once you are done with the first one, you take a break, and then at 2 p.m. it opens up, you do the E&M. Everything is the same besides content. So when you actually go to the page and look at it, it gives you the exact same, going back to my screen now, it gives you the exact same question to look at in terms of a long FRQ example. It even gives you the mechanics 2012 example for an E&M type question. So those are the only 2 examples that they give you. However, what I have started to do, and I don't know because it's brand new this year, and I've just finally started to look at it because until a couple weeks ago, we didn't really need it because what we have done in the past always works out well, is I have opened up, and I don't even know if I can even find it here. So what I have done is I've tried to open up, I've tried to open what do they call it? Let me re-log in here. They progress checks and things like that where you can, their site is so difficult to navigate. At least I find it's very difficult to navigate. So let's see here. Here we go. So let's see if I can, I'll show you what my end looks like. I have no idea what your end is going to look like. So let's do this right here. So what you're looking at is, I don't want that. There we go. What you're looking at here is my list. Okay, so I got my second and my third hour for, here we go. So for E&M, here's my second and my third hour. For my mechanics, there's my second hour, my third hour. And so if I click on any of these, let's go mechanics, second period. And so in doing this, so what I have here, I don't want that. Back to the course list. I want, and of course I can't see it. There should be, what I'm trying to find here, well, I'm struggling, so I will look for it again. But basically what it is it's progress checks for you. So unit number 1, and what I've done is I opened up all the multiple choice. I know there's no multiple choice for what you're going to be doing AP test-wise, but it's still good content to learn. And these things are going to be optional. You know, I'm going to look at the UTs and your Google Forms. This is AP preparation, and because I don't know how to make it work right yet, I'm not going to make it a requirement for a grade. But you got mechanic, you've got multiple choice, and you got FRQ. I opened up unit 1 for mechanics and for E&M. I've got those both opened for you. So what you need to do is go to College Board. You logged in at some point because you did this join code thing. So you just got to basically find that, log back in and do some searching and give me feedback. Let me know how it's working out. If you can find things, if you cannot find things, just let me know. Because again, I think that's going to be a good resource for us to use. Like I said, I don't know what it's gonna look like. Let's see here if I can do this real quick. Let's see. I don't care who's taking the exam. What I want to see. Oh, I'm on a. Yeah, it's not working. Okay, so at this point, I'll come back and see if I can figure it out. So yeah, so we're doing the same thing. So for whatever reason, everything that they sent out to us as community members, because I get emails from the school as a parent, they never actually spelled out to you, the students, that first hour was 8 to 11, and that is like carved out on a Monday. That's carved out so that no one else takes that time slot from you. So that if I want to meet my first hour kids, I know from 8 to 11, no other teacher should be doing anything that's required, kind of a thing. And then second hour is from noon until 3. So you get a 3-hour window that is designated for each individual hour. That doesn't mean that you're only getting, 3 hours of, that's it. That's not what it means. That's just our time slot. Expect that you should be able to do 2, 3, 4, 5 hours of work throughout the week. So that's how it should be continued. Now, obviously, I don't know how each teacher is doing their own thing, but you know how mine works. I do a second hour meeting, which is this one. I do a third hour meeting, and I don't care if you come to both or neither or one or the other. It doesn't matter to me because these Zoom things are optional. You're going to have attendance, and you're going to show your activity in class through those Google Forms and through your UT assignments. So, and then you've got Tuesdays and Thursdays as additional. So I know some teachers have scheduled things on a Tuesday or Thursday on top of what they're already doing. So you have those opportunities as well. So again, to kind of consolidate everything, to recap everything, go to the Google Classroom page if you haven't, And it is the second posting. What was this posting here? I can only read half of it here. So, oh yeah, so this first posting is me telling you, log into AP Central, College Board, log in and find your AP Physics class, and there should be resource view practice questions. And I have it, I think I have it clicked so that when you answer questions, you can look at your results right away. You don't have to. No, I'm not using this as a grading method because I can assign something to you for a week and then you can do it. It's almost like a UT assignment. You can do it and I can see how you did, and then I can release to you what the results are. I don't want to do that. I want you to see results when you want to see results. So get on there, try it out, and give me feedback, even if it's feedback that's good, that says, hey, yep, it's there, it's easy to follow, or if you're struggling, and we'll work through it together. The second posting there is, again, all the sources for what you would need for the AP exam. Those are things that I saw that I found, put them together in one spot that I think is going to be useful to you. And if I find some other things, I'll continue to post those. You still get the equation sheet. They made it a point to mention that every type of math that you're doing, all the math calculations and everything else, should be able to be completed with a pencil and a piece of paper. But you will still be able to have a calculator. And so they're not expecting, they're not going to give you lots of calculations where you've got scientific notation and squares and square roots. They're going to be looking more at relationships. So, but you'll get the equation sheet. It says you should print it off for yourself, or at least have it on your computer screen somewhere so you have that. And then you can use calculators if you want. And again, 25 minutes for the long FRQ, that's new for us, and then 15 minutes for the short. And that's both tests, as well as AP Bio for you AP Bio folks. All right, so with that, do you have any questions regarding anything? RCS, grading and attendance, AP exams in general, AP exams for physics, or any of the review onlines? I'll start, I'm going to continue posting UT review onlines as well. So I think we're up to 6. I've got 10 total. I'm pretty sure probably 9 and 10 are probably more magnetism, so I will not bother posting. If it's all magnetism, I will not bother posting those. If it's got some things that are going to be useful for the exam, I will post those and tell you to skip the ones that are magnetism or whatever. So I'll get those posted as well. And again, the due dates are May. So any questions? Do you think colleges are still going to give credits? Absolutely, I would imagine. I think they would be insane not to. I'm sure there's a lot of money at stake, and I'm sure that if the colleges, the institutions start saying, hey, we're not going to give credit, I'm pretty sure College Board's going to be like the mob and say, hey, what are you talking about, kind of thing. So I'm pretty sure that they're still going to give you credit.
Mr. Laura, I joined a little bit late, but I still want to know like what the attendance policy or like for the grades is going to be.
So attendance policy and attendance policy and grading is going to be basically, I'm going to give Google Form surveys. It's like a survey on Google Forms. I'll put the link each week. We'll get a new link, and it'll have some basic physics questions about what we're doing, and you answer them. And that way it shows who answered, what their answer is, and when they answered. So if you answer it a week late, it's not a big deal. If every single thing you do is 1 week late or whatever else, again, it's probably not really that big a deal. My physics class, I'm going to be giving answers to all of those. And so if I have someone that just keeps on waiting and they turn in a week late because they got the answer, that's a different story for a different class. It doesn't bother for you. So just answering those and making sure the UTs are completed. They don't need to be 100%. I mean, quite frankly, technically, they got to be 60% because that's passing. So as long as you're doing the Google Forms that I send out, and as long as you're keeping up on your UTs, you don't need perfect scores. If you're getting them right on the 7th try every single time, you're going to be fine. And obviously, we know that it might happen once or twice. That doesn't happen for every single question that you're given. So,
thank you. Appreciate that.
Absolutely. Question on Kirchhoff's laws. I'll do one of those in just a second. Any other questions in general on anything? AP test, classes, And obviously, our question and answer doesn't end with Zoom. You can send me a remind message. You can post to the stream, and I can answer things there as well. Are our current GPAs calculated on the grades we had before leaving? No, this whole second semester doesn't count for anything in terms of your grade point. It will not hurt nor harm. That's the same thing. It will not hurt or help your GPA. It will not change it at all. That is what I've been, that's what was told to me. So basically whatever your GPA was in January, it's going to stay there. So if you're a senior, I think your GPA is done. If you are a junior, then you're done until next year. That's my understanding. I know some people said, well, I was so close to, I needed a bump in my GPA and I was hoping on this semester. I totally understand that. And I don't know what to tell you. You can always forward that question on to someone that is above me, because I'm at the bottom of the hill, the bottom of the pile. I just do what I'm told. Luckily, I teach physics, so it scares everybody away from me. Do you know how exactly the AP test will work? Is it more like an online form where you type in answers, or is it write out on paper and upload a picture of your work? I don't know the answer to that 100%. I will look it up, but my original interpretation was that it's going to be something that you are going to be typing into a computer. But that's a good question, so I'll make sure I put that on my list, and I will get an answer to that, whether it is whether it's through a word processor and you're literally typing in, or if it's something that you're writing and uploading through photographs. Let's see here. Do I get to keep the textbooks? The textbooks you have, well, not forever, but till the end of the school year, absolutely. So yeah, use them. You got them, keep them, use them, and then I don't know how they're going to go. Obviously, people got to get back in the building to get your personal belongings and turn in books and all that kind of stuff. So I don't know how they're going to end up doing all of that. Hopefully, by the time May or June rolls around, we're kind of out of lockdown, and going into a building isn't a faux pas anymore, and we can do it that way. So. All right. Any other questions? I'm going to pull up, let's see, Kirchhoff question number 2. I'm going to pull up a UT question that someone had posted. And while I'm doing that, if you have other questions, go ahead and post them on there. I don't see the screen currently. Okay. All right, so what I'm going to do is I'm going to shift over and do question number 2 from the Kirchhoff's laws online. And again, for those that showed up, those of you that showed up a little bit later, there's nothing new to be posted this week in terms of content. I might put out a new set of reviews that have an endless deadline, but there's going to be nothing new because everything that was going to be new this week, I posted 1 week early for those that wanted to work through spring break. So basically, I figured put it out there early and then don't assign anything the week after. So anyways, nothing new this week beyond maybe more reviews popping up. So all you're doing this week is making sure you understand the last bit of electricity. Okay, so first question involves Kirchhoff's laws. We have a question being asked about question number 2. And so I think we've done one like this before. And so in looking at something like this, I'll use my cursor here. First thing you have to do is make a guess. And the guess really doesn't even matter. It doesn't even have to, you don't have to be right. You just have to have a couple currents going through the wires, coming together, going apart. Here they tell you what the direction is. They basically say, you got I1 here at the bottom going left, I2 going to the left, I3 going to the right. And we draw out our resistor systems like this because it's convenient. Everything is parallel. Everything is left and right. all the up and the down. There's no resistors on the up and the down, so everything's left, right, left, right, left, right. Second thing you do is you do a junction rule. So looking here, I1 and I2 come together right here. So my junction rule says I1 plus I2 will equal I3. There is my first equation. I'm going to end up with 3 loops, 3 equations, plus junction rule for a 4th equation. I'm going to solve that system. Now what I do here is I'm going to go through and I'm going to look at each loop I see and watch my cursor. I know it can be kind of, I know the cursor kind of jumps around when you look at the video here, but so I'm going to look at the outside loop. So watching right here, I go across the bottom, I go up, across, and down. There's one full loop. Loop rule must apply, which means add up all my voltages and I get 0. So I'm going to have positives and negatives adding up to 0. I have a lower loop right here. And then I have an upper loop at the high point. The upper loop and the outside loop make sense because current is flowing that way. We'll take a look at those real quick. So I've got one resistor in this branch, one resistor and one battery. The way the battery is connected matters. The long side is positive, the short side is a negative, which means that this is the low side and this is the high side of my charge pump. I have one resistor here. Down here, I have 2 resistors. They are in series with each other. Just because there's something in between doesn't change the fact that this whole branch is everything in series. So I have a 1.2 and a 3.8. Add them up and call it a 5. So I've got my 8.7, my 5.8, and a 5. I've got 2 batteries. I can combine them if I want. I don't need to. I'm just going to leave them as is. So going through, pick a loop. I'm going to do the outside loop. Pick a place to start and pick a direction. I'm going to go clockwise because that's the direction that my current points. Clockwise all the way around. That makes sense to me. So as I go through, I do my loop rule. My loop rule is going from the low side of this battery to the high side of that battery. That's a gain. That's a positive. So my first loop rule statement is going to be 8.4. I have these 2 resistors. You can do them separately, and I'm going to end up with R times I1 and this R times I1. We know how to do math. We can put those together, mathematically speaking. So I've got my 5 ohm resistance, 5 ohms of resistance in this branch with the current. Now what you have to remember is I am analyzing this. I'm going through my loop, and I'm going, in this case, with the current. Current points to the left, and I am moving as I analyze to the left. So as I follow current, think about a river. As I follow current, current flows downhill. So my water loses potential energy as it goes down through the river. Our charges lose their energy as they get pushed through a resistor. So this is going to be a minus. Voltage is current times resistance. V equals I times R. So I1 times resistance of 5. So I end up with 8.4 minus 5 I1. Next, I get to this battery, going from the low side to the high side. That's a gain. I'm going up. So I add in another 1.4. What I could do is I could say, you know what? 8.4, 1.4, let's just add those together because of the way they're connected. Let's call this branch, let's call it a 9.8 voltage and a 5 ohm resistance. And the math supports that. So I end up with positive 9.8 so far, negative 5I1. Following my cursor, I go up. I'm going across the top here. Now I'm going through this resistor. I'm going with current I3. So with the current means it's a drop in my potential. So I get another negative 8.7 I3. Keep going across, down, and we're back to where we started. We completed one loop. All of that equals 0. So real quick recap, 9.8 minus 5I1 minus 8.7 I3 equals 0. There's my outside loop. Top loop, I do the same thing. Plus 3.3 minus 5.8 I2 minus 8.7I3 equals 0. That's an easy one. The hard one is the bottom one, because watch what happens. I go through the bottom. I'm going to go clockwise again. I go through the bottom. No big deal. So I get 8.4 plus the 1.4. I've got minus 5I1 again. Here's where it gets weird. Now I start going this way. I am moving in the clockwise direction, but you'll notice I am going against the current. That's not a problem. What happens if you were to walk against the current in a river? You are literally going uphill. You are going to a location where you have more potential, more energy. So this right here is not minus 5.8, it's plus 5.8 times I2, because I just went against the current. I went to a location of higher potential. Now this battery, it doesn't matter which way current's going. I'm on the high side of the battery, now I'm on the low side. That's a drop, negative. So to recap, positive 9.8 minus 5I1 up here is a plus 5.8 I2 minus 3.3 back to where I started equals 0. And I have 3 different loops, top, bottom, and the outside loop, plus the junction rule for a 4th equation. Those 4, put them into a system, do a matrix, do whatever you got to do. But you have to use the junction rule equation. Otherwise, everything just cancels out and you don't get any answers. So that's Kirchhoff's laws, question number 2. And I did something like that in the notes presentation from, I think, 2 weeks ago. And I think we had a question on that in an earlier example as well. So if you go through some of the old videos we have from YouTube, go on there and you will find, those. Another example where I think I had some things actually written out for you to see, perhaps. So there's the first question we had was that one here. Next, can I go over number 15 on UT number 22? So let me open up online number 22, and we'll take a look at number 15. Online 22. This deals with RC circuits, which was the new content that I posted at the beginning of spring break, and that's what you're going to look at. If you took the spring break off, that's fine. That's what you're going to look at this week. So question number 15 on 22. So question number 15. So this is online number 22, RC circuits. Question number 15, galvanometer. Okay. It says, consider a galvanometer with an internal resistance of 54. Obviously, everyone's going to have their own value. If it deflects full scale when it carries a current of 0.7 milliamps. So remember what a galvanometer is. It's a little needle inside a wire, inside a coil of wires. And if I have too much current going through, the needle reaches a maximum. And I can't have the needle deflect anymore. So if I, according to my question here, 0.7 milliamps, if I get to 0.8, 0.9, 1.0 milliamps, the needle can't go any further, and I can't measure that. So what is the value of a series resistance that must be connected if it is to it? If this combination is to be used as a voltmeter, having a full scale deflection for potential of 0.8. Okay, so we got a couple things that we can use to, oops, it just disappeared on me. Okay, let's not do that. So, all right, well, that's opening up here. Okay, so what we need to do is we want to use this as a voltmeter. And so what I'm going to do is I am going to stop sharing this screen for a second and share a different screen. What I'm going to share is our page of notes that we had looked at. And so right here talks about our galvanometer. Now this is if we want to use it as an ammeter, so I'm going to skip forward one slide, and so this is how we use it as a voltmeter. So there's our needle that gets That gets buried if we put too much current through it. So if we're going to use it as a voltmeter, number one, and it's kind of blocked right here on the right-hand side, you can see, but basically if I'm going to use a voltmeter, I need to connect the voltmeter in parallel with whatever I want to measure. That way I know each branch has the same voltage. So if I have the thing I want to test and I have my voltmeter connected and it says this is 2 volts, then I know this branch has to be 2 volts as well. So that's how we connect that. The inner workings are inside this dotted line here. These are the inner workings of my voltmeter. There's my coil. My coil has some resistance. This right here is called my shunt. So basically, if I have, if I'm trying to measure the voltage going through here, well, I need to take some of the voltage away because I want to measure with my coil here something that I want to make sure I measure accurately, but if I have too much, I can't measure accurately. So this right here, and I have it written right here, if the voltage is too high, our shunt will remove some voltage. Think about something that's in series. I have this loop rule, right? As I go through, I keep on using up some voltage. So if I look at my screen here, my coil is going to use up some voltage. I want my shunt to use up some voltage. And what I want is I want the shunt to remove enough voltage so that the little bit that remains can be accurately measured by my coil. And so I have something right here kind of set up. So full scale is going to be when I have my current going max. So that current is going to be, so if I look at the voltage on my voltmeter right here, and I believe the question asked us to measure a particular value, that voltage is going to be the full scale current that I have multiplied by the overall resistance of my system here. They're in series. The overall resistance is the sum total. So the voltage that I read is going to be the full scale current going through multiplied by the combined resistance of the two of them. So if I scroll down a little bit, so that just kind of shows how they work, how they function in real life when you have one. So if I go back to sharing this screen right here, so now going back here, so we have our so we've got our full scale current right here. I'm going to want to change that to amps. I have, let's see, for my question, it says that we want to be able to, is to be used a voltmeter having full scale function of 0.8. So that's my VAV is going to be that 0.8. So that's going to be my, my total there. So my 0.8 is going to be my voltage. And so I have my current there. Let's see here. So yeah, so if I look at this, I have my voltage AV from my previous screen is going to equal my full scale current multiplied by the total resistance. They're telling me this is the resistance of my coil. So V equals I times total resistance R. That total resistance is going to be a combination of this coil and the resistance of my shunt. They don't actually use the word shunt in here. They just ask what kind of resistor do I have to use. So one more screen share again, back and forth we go. So there is the voltage given to me. I was given 0.8. I'm told the full scale current is going to be 0.7 milliamps converted into amps, and that's going to tell me how much resistance I'm going to have. I'm given this was 54 for me, so what does this have to be? So mathematically speaking, once you know what you're doing, mathematically speaking, it's very simple, but obviously understanding how the galvanometer works as it relates to a voltmeter, that's the challenge for that question there. So we had a question on number 2 from Kirchhoff's laws. Question number 15, which we just did. Can I do number 9 on review 3? I'll get to that one in a second. So let's go back here. So is the current in the bottom branch consistent? Okay, so yes, current I1 in our Kirchhoff's laws example, current number 1 was the same throughout the entire branch because it's one single branch, so I got the same current everywhere. Review number 3, question number 9. So let me open that one up. I usually have these opened up previously, but I didn't just because there's so many. It takes up a lot of space on the screen. So I don't know about you guys right now. It's really windy out here. Can't wait to go for my run. Yeah. All right, here we go. And review number 3, question number 9. Okay. All right, walking by a pond, you find the rope. So we've got a length, a height given there. Let's see, you said use rope to swing out over the pond. It's a bit frayed, support your weight. You estimate that the rope might break if the tension is 67 newtons greater than your weight. That's a great estimation. Your mass is 31 kilograms, so you know what your weight's going to be. This is a very, very small person, 31 kilograms. So you're talking, what, 70 pounds? Let's see. You grab the rope at a point. Swim out. Okay. In the figure, you start at location 1. So we start at location 1. At which point you release the rope, begins, you let go here at 2. So what is the maximum angle? Okay, so what is our maximum angle going to be? So in looking at this, I've got circular motion. I have conservation of energy, but I have potential energy here at location 1. And I'm going to use location 2 as my 0 point. I think there's a second part to this question, probably asking how far you fall or something like that. So I can answer question number 10 later. I'm going to say question number 2, or I'm sorry, position number 2. I'm going to say I'm height 0 there. So I go from all potential into all kinetic. I know that this right here is giving me some upward pull, some centripetal force. If the rope doesn't break, I swing up. I'm told exactly what that maximum is going to be. So I've got my 31 times my 9.8 plus my 67 right here, because my spitball estimate is that the rope can withstand 67 extra newtons. So I know exactly how much force I'm going to have. And so I'm going to use circular motion, gravity down, normal force up. I'm going to use that to figure out how fast I will be traveling. Actually, you know what? I'm getting ahead of myself because it doesn't really matter how fast I'm traveling. So there it is. So I can figure out what my maximum speed will be at the point that this thing rips. So 67, whoops, get out of there. 67 plus my weight is going to be the tension in the string. That's max. That's the strongest my string is. So I'm going to use my circular motion. So my net force equals mv squared over r. And what I can do is I know r, and I can use that to solve for v squared. And then over here, my potential energy turns into kinetic. And that kinetic is based on v squared. So I'm using circular motion at location 2. Net force equals mv squared over r, at which point I have all kinetic energy. What would my height be? Once I have my height, then I can extend the line over here, and I can figure out what this angle has to be because I have a triangle. If you can visualize my cursor right here, adding in a horizontal line right there, I know what this height is, which means I know what this height is. So I know this leg of a right triangle. I know the hypotenuse, and I can figure out what the angle is right there, which will be the same as where they have it written. We get down to question number 10. If you begin at this maximum angle and the surface is 1 point, at what speed? So question number 10, the second part of that is just a kinematics, 2-dimensional, you throw a rock off of a building question. Okay, so hopefully that helps with review number 3, question number 9. Any other questions? This is a marathon session of a Zoom meeting compared to what we've had in the past, but that's all good. How can you tell if something is charging or discharging? So basically, what they're going to do in a question like that is they are going to tell you that something starts off charged, a capacitor. They're either going to tell you that the capacitor starts out charged or starts out uncharged. What they might do is give you a roundabout way of looking at it. And typically what they'll do, and if I may, let's find the right slide here, because there was a question just like that. We're going to do this one right here. So if you take a look at the screen right there, this question right here, notice the switch A and B. If I switch it to A, the battery is connected to the capacitor. So when I switch it to A, it's going to be connected with the battery. If I switch it to B, it's a complete loop without a battery. And so if you look at their phrasing here, for a long period of time, the switch is at location B. So that's them telling you we have this capacitor connected for a long time. That's them saying it's uncharged. Then they say at T0, we switch it over to A. So that means you know that it was connected for a long time. It's dead, it's discharged. Switch it to A. Now this battery will begin charging up my capacitor. And then when I look at number 13, much later, great sounding science words, much later is implying that this capacitor is charged up to max. And then you're going to switch from A over to B, so you know you have a fully charged capacitor that is now going to discharge through the 1 and the 3 mega ohm resistors. Keep track of all those units, folks. So to answer the question that was posted in the chat, how do you tell something is charging or discharging? They'll either tell you that you start off charged or uncharged, or they'll give it to you in a roundabout way. I'm done. Any other questions? So lots of information today on a lot of different things. So don't be shy about sending me text messages asking about anything. I am hearing nobody. I am seeing nothing new on the chat. So with that, I'll stay on here for a few more minutes just staring at the screen in case something comes up in the chat. But unless you have something else you want to add in, question-wise or comment-wise, done. Hope you all had a nice spring break, whatever you could salvage of it. The first few days are nice and warm and sunny. But yeah, lots of wind going on right now. Have a good run. Yeah, it's I'm gonna get out there and try to run in 26-mile-an-hour wind. I'm excited. Anybody can run when it's nice out. Looks like everyone is slowly logging off. Sounds good. I'll stay here just in case any other people have questions, but if you're good, you can wait around or log off. It's up to you. And don't forget, jump on College Board and let me know how it works. I didn't miss any questions. So Dylan, in the group chat you wrote down either, did you, was that answering Sophia's question about how the answers are being input? often will I check the College Board website because the FRQs require teacher feedback? I'll jump on each day and see. Like I said, I'm getting used to this because the navigation of this site from my angle it's not very, there's so much stuff out there. A lot of it's useless. So I will be on there quite often trying to make sure that everything is available to you, whether it's my feedback or clicking boxes, allowing you to go to the next thing or whatever it is. So how often will I check the website? I'll be on there a couple times each day until I'm satisfied that everything's running smooth. To answer Ethan's question. All right. So with that, it's been, we've made it a full hour. All right. I will save and post this to YouTube in case you want to go through and see anything again. So Colin, enjoy. I'll make sure I don't get hit by any falling trees when I'm running. So. Okay, everybody. Then I will see you. I'll be here on Wednesday for those that want to join at 10 a.m. But if not, because you're busy, I understand. But that's when I'll be on the air next. So try out that College Board website and tell me what you think.